And there we go. So what we're going to do today is very briefly first look on the whiteboard at a couple of very important concepts so that you will be able to read flow charts related to what we're going to be doing. And then we're going to go over the entire first chapter of this book here. So we have almost 30 pages of things that we're going to be looking at. And I have asked you guys to look at it before, so this shouldn't be horribly new to anybody. If you've been entirely ignoring me, then of course you haven't been looking at chapter 1 at any time, and this might be a bit hard for you today. But this is our goal. We are going to go over these things here. Okay. So first of all, we've been learning about how to put data into variables, how to print it out, and how to make calculations. I'm going to go on the whiteboard to make a couple of drawings for you guys, and then we're going to replicate these drawings in code. So if we want to make a flow chart to explain the structure of our code, anytime we're making a statement like assigning a variable or printing something out, we usually make a box for it. So we could make a box that, for example, x is valued 1. We're assigning 1 to x. Then we would want to possibly do different things depending on the value of x. Let's say that x is 1, and originally here I had assigned that n would be 5. I could also make one single box that says that n is 5 and x is 1. Nobody really cares. It's a flow chart. It's just a visual aid for what's going on. So let's suppose n is 5 and x is 1. Then we could do a condition, and this is the new stuff we're going to be looking at today. Conditions are usually diamonds. So we could check stuff like, is x still less than n? Okay. And if x is less than n, we could do something. And if it isn't, we could do something else. So we could make two different branches here. We could make a yes branch and a no branch that go into different places. So let me actually put these together in one single box so we have less boxes. And I am going to add another variable f. Okay, so if x is still less than n, let's actually make it less or equal to n, then I am going to replace f. F is going to be what f used to be before, but it's going to be multiplied by x. Okay? And if x is no longer smaller than n, then we could print, for example, the value of f. So this is a condition. We evaluate this thing here. If it's true, we do something. If it's not true, we do something else. I'm going to give you guys a photo of this on Discord. I'd like to remind you, you can go on the voice channel. There's a couple of clever people on the voice channel. So you can talk to your classmates there if you get confused. When I'm done on Twitch, I will join you there as well. So let's type here. This is a condition. Of course, I could nest the conditions as much as I want. I could put a condition that depends on a condition that depends on the condition. So I could make like a little box, and then I could have a diamond, and one side of the diamond could point to another diamond. Here I could have a box, and one side of this diamond could point to another diamond, and then here I could have a box, here I could have a box, and here I could have a box. So these conditions, in C language, we're going to call them if. So each one of these is going to be an if. And the part that we do for the if, that's going to be the true condition. And the other branch is going to be the else. So if something is true, we do the left side. If it's not true, we do the right side. We could also have a condition that doesn't have the other side. That if this is true, we do this. If it isn't true, we don't do anything new at all. And if I want to convey that I only do something If something fulfills and not anything new otherwise, I would have a structure where like there's a box. Then there's the thing where I check if I have to do something cool. If it's the yes, I go to the yes one. And then if it's a no, I skip ahead to whatever would be after the if. So this is an if that doesn't have an else. So here I have an if. If it fulfills, I do this. If it doesn't fulfill, I continue as normal. We're going to look at this structure in code as well in a little while. Actually, we can look at it right now before we draw anything else. So let's look at these things in C code. What do they look like? So you guys can use online GDB, or you guys can use the code blocks that you installed last time. I am going to use my little black box here. Okay, so let me go to my repository. Let me go to chapter 1, and let's make a new example for this semester. So I called it cont.c. I'm going to include the stuff that lets me print so we can see what my program is actually doing. Let's hide the Discord for now. And we're going to want to try conditions. So let's make the main. Let's have it return 0. We've done all this kind of stuff before. And then I have my variables. Let's suppose that they're integers. So I have an integer f, it's 1. I have an x is 1. And I have an n, and that's a 5. Then I want to make this condition that I send you guys the picture of. If x is less or equal to n. If you don't remember how to type less or equal, you're going to go look at your reference card. Here under operators, all of this is written. So it's important to have the reference card. So if that thing is smaller than n, then f is going to be f multiplied by n. I could also type this way. F is going to be its old value multiplied by n. Let's leave in a comment the other way to write it. If it isn't, then we would print. So in the picture, it says, if it's less, we're going to do the multiplication. If it isn't less, then we are going to print the value. Okay? So here I would be printing the value of f, so it's the same stuff as on the whiteboard. So this is the picture we have now. If x is smaller than n, multiply, actually we're multiplying by x, not by n. If not, we print. Okay, I'm gonna leave this here. I'm gonna make another terminal just like this next to it so that we can compile and execute. Okay, so I'm compiling cont.c. And then I'm running my program. It didn't print anything. Why didn't it print anything? Because x was smaller than n. X was a 1 and n was a 5, so nothing was printed. If x were larger than n, let's make it larger, let's make it 10. If I recompile and I run, now it printed the value of f, which was 1. Okay, so this is the very first picture. Let's take a screenshot of it so it goes together with the picture. Of course, this program is pretty dumb. It's not really doing anything interesting. And if we want it to do something interesting, we're going to need to, oh, I'm really sorry. We're going to need to add more stuff to it. I forgot to change the screens. Thursdays are very long days. Okay, so I wonder how I could make it so that I would notice easier that you guys can't see stuff. I could maybe be on the Discord channel and you guys could say something, but then I need another headset. I'm sorry, I'll try to remember. So this is exactly what it says on the board now. F is 1, x is 1, n is 5. If x is smaller than n, we multiply f by x. I could also write it the second way. If it's not, we print. When I compiled it and executed it, it printed nothing. But then if I change x to be 10, then it's going to print out a 1 because f is equal to 1. That's how far I've gotten now. Now I have to go back to the whiteboard, and I'm really going to try to remember to switch it back when I come back on the computer. We're going to introduce a cycle in this thing after testing one tiny little difference. So let's try to make it so in the picture that it's going to print out the value of f regardless. So I want to modify the diagram to do this here instead. So I want it to always print regardless of whether x was smaller than n. So let's go look at what has to change in the picture. So now, if I wanted to always print regardless of whether this happened, I need a structure like this one here, where I don't have an else clause, I simply skip. So let's take the little one away and let's modify the big one so that we don't have an else. So that instead of the no only going here, I would also make the yes go here. So after the increment, I would print. And if I didn't do this, I would also print. So now I have modified our picture to match the second version of the code. Let's take another picture here. We're going to continue modifying this picture until we can actually make it do something reasonable. It's still doing just dumb things because it's still a very simple diagram. So now the difference is that we're always printing regardless of whether the condition is fulfilled. Otherwise, it's the same program. So now let's say I would like to make an algorithm that calculates the factorial of n. That would be multiplying together the numbers 1, 2, 3, 4, 5. So how do I modify this code? I would want to, after multiplying, I would want to increment x because I multiplied by 1. Then I want to multiply by 2. Then I want to multiply by 3. So I want to keep multiplying until I reach 5. So now I need to make something called a loop. I need to make this thing iterate. So I could say that while x is smaller or equal to n. Instead of if, it's a while. I'm going to keep multiplying while this is true. And after every multiplication, I am going to increment x by 1. So here we multiply f by x, and here we increment x by 1. So if I start doing this first, f is 1. I multiply by 1, nothing really happens. Then I multiply by 2. Then it's 1 times 2, it's 2. Then I multiply by 3. 3 times 2, that's a 6. I'm so sorry, guys. I haven't eaten lunch. I'm dying here. Give any time I do this, just write something on Discord, please. As soon as it happens, please. Okay, so I've switched the if to a while. We want to repeat it. So as long as x is smaller than n, we're going to keep doing this. We're going to do the multiplication we did before, but we're also going to increment x. When x isn't smaller or equal to n anymore, so in this case, when x is 6, we're not going to multiply anymore, and we're going to print. So let's going to make it print something a little better. Let's have it print that the factorial of n is valued f. Going to compile this, going to execute it, and it lets us know that the factorial of 5 is 120. So now let's take a picture of this here on Discord and go back to the whiteboard and try not to forget that we were on the whiteboard, so we can update the picture so that the picture does the same thing too. So that in our picture, we're conveying the repetition. And this is going to be really easy. We just need to make arrows go backwards. We need to make the arrow go back to where we were before. Okay, it didn't let me post the screenshot, probably because my neck is in it. So now Discord thinks that there's naked people here. Okay, so let's try again with less of my screen. Okay, this is much better. My neck isn't anymore in the picture. It's not obscene. Then I'm going back to the whiteboard. You guys remind me as soon as I come back if I forget it on, okay? So we want to make it repeat. So after we do this multiplication, we don't want to print straight away. We want to go back. We want to go back here. So first we go to the condition, we do the multiplication, and then we go back. But now there's a very important thing missing. I need to increment the x so that x actually grows. So we're going to add here the part. This is where f gets multiplied by x, and then x gets incremented by 1. So now I start, I compare. It's less, I multiply and increment. I check again. And I keep checking again. And when it's not smaller or equal anymore, then I print. So now we have a picture. I'm going to take the photo and then I'm going to switch the computer. So now we have a picture that's actually a cycle. We can do a repetition. Changing, 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 changing. Okay, there we go. We have actually changed back. So this is a while loop because I used a while construction to make the loop. In C, we have another way to do this too. That's also very useful. We're going to leave the do while until later. I could do something called a for loop. The for loop's kind of nice because I can add a little bit of stuff to it. I could say that while I want to start with x equal to 1. I want to keep going while x is smaller or equal to n. And after each round, I want to increment x. I compile, I execute. It does the same thing as before. So this is like a shorter way to type the while loop. I'm going to have to draw you guys a picture of what the for loop would look like. Well, actually, we don't. We already have it. The for loop looks exactly what we have here. The for loop is going to first do the x equal to 1. Then it's going to compare. Then it's going to do the multiplication. And then after this curly brace closes, it's always going to do the third part here. So it's going to do this one time, then compare. If comparison is true, it does this. Then it goes back to this. Then it compares again. It doesn't repeat this part. It just goes to the comparison. If it's true, it multiplies. And then it increments. Then it compares. If it's true, it multiplies, and then it increments. So that's how a for loop is going to function. So now we have in our possession two new things we can do. We can do conditions with an if, and we can do loops with a for or a while. Let's make a couple of polls. So the if is the stuff I want to do when the condition is true. The else is the stuff I want to do when the condition is false. I don't have to have an else. The else part is optional. I can have an if without an else. Then I have two ways of repeating things. I have a while loop. The while loop repeats as long as the condition is met. And if you want to do anything before it or after it, you have to do it manually. You have to put stuff before the while or before the for. I'm going to make an alternative copy of this file so that we have the condition with the for loop and a condition with the while loop. So we can look at both of them later on. Let's add, let's actually change the name of this. This is going to be a cond for. I don't like underscores. And then we're going to copy the cond for into a cond while. And we're going to return the cond while to the while loop version. So the same stuff as here, but with a while. So if it's a while, I have to do this part here first. And this part here at the end, I have to do it here on the inside. So to make a while from a for, you just move the front part up here and you move the tail part down here. And then you will have, here we have the cond for. Let's make this one, the executable called cond1. And I'm going to compile cond while into an executable called cond2. So now if I run my cond1, I have the same behavior as I get from my cond2. Adding cond while, and I'm sending them both to the repository. I'm going to commit loop demos, and I'm pushing them in. So now let's remember how to get access to the codes I am writing for you guys. Oh God, I was in a different computer the last time I was doing stuff here. So this computer isn't up to date. Okay, what's the file that I was having trouble with the demo.c? Didn't actually have one. Okay. So let's go look at the new files that I just uploaded. So we're in the C repository. We were in chapter 1, and this is where I want to be pushing stuff, but it didn't want to go because I had a conflict. So now I have sent them in, and I should have a cond while over here. And did I never add the cond for? We have a cond for, and we have a cond while. Let's get the link to the chapter 1 repository. Okay, so I'm hoping Luis will catch on to the if in a little while here. I think everybody else seems okay. We're going to be going it over, and the book's going to be going it over many, many, many times, so there's no particular reason to panic. So just for now, we have to remember that while and for are ways to make loops in C. So either one of those, you can use them to do the same stuff. They just look a tiny little bit different. They're both meant to do repeated things. The other important thing we need to remember is that when we make flow charts, like the ones I made you guys on the whiteboard, we make diamonds for the conditions. We indicate which branch is a yes or a no. Some people, when they learn to program, they use little tools where they draw the charts, and then those little charts get animated. Let's go look at what this looks like. It's a very 80s way to go about this, but I'll show you guys. This is a software I'm never ever going to install. So basically, instead of writing code, for some reason they're writing code in Excel. I'm going to speed this up a tiny bit. Please, guys, never ever type code in Excel, like never. Uh, so he first designs a code, apparently with no intention of actually running it. And once he's designed the code, he starts building it with the software. Like anytime you want to start the program, you put a circle. When you want to end the program, you put a circle. The assignments of variables, he's putting them in these boxes. He's putting tilted boxes when you're printing out something. The arrow points in when you're taking input from the user. We're nowhere near to doing that yet. It points out when we're printing. And then we make these little diamonds that they call selections for the conditions. They have the yes and the no branches. And then we have a loop when we just return from the condition to a starting point. So this is very much like what I was doing on the whiteboard, except that these people, they make their entire program like this kind of a drawing. And then they will look at how the drawing behaves while they're running the program. So if you see anybody else in FEMA doing stuff, they might be doing this. They might be doing strange handwritten notes and then these animated diagrams. What programmers actually usually do is the other way around. You write your code, and then when you need to explain it to another person, you make a flow chart from the code you have. So basically, there are things that convert those. Let's find one that converts C code. What's the best tool to generate a flow chart? Oh, I freaking hate Quora. I can't find anything here. So there's one thing called flowchart 8. You will put your code in it, and it's going to spit out a diagram that corresponds to that code. I'm going to be surprised if there isn't an online thing that would actually work with this. No, these are for just text. But it's like the concept of flowcharts, it's nice for thinking about conditions and cycles. But guys, I promise you, it's not really something you would need to do anymore. If you want to make a picture, just drawing by hand diamonds and boxes, you could use those. The thing those people were using, it's called Raptor. I personally really wouldn't use it. Like an engineer in their profession, they're not going to use something like that. And if you want to just make a drawing with diamonds and boxes, you can do that in PowerPoint if you want to. But flowcharts were a common way to do things when compiling would take all night. Like when you'd have to compile a program and it would take all night to compile and you'd go pick it up next morning to run it. And it was really expensive to make a mistake because you would spend the entire night in vain compiling if your code didn't work. So people would take a lot of precautions and draw a lot of pictures to make sure their code's doing exactly what they think it's going to do. But these days, compiling takes a fraction of a second. It doesn't really cost us anything. So spending a lot of time drawing what's going on, it's not necessarily as helpful. When you get used to programming, you read the code the same way. When you see a while, you know it's a repetition. When you see an if, you know it's a condition, and you don't really need the drawing. But it's important that you guys know that usually the diamonds are conditions. If there's arrows going backwards, those are loops. And they tend to put slight little shapes on the boxes, depending on whether it's calculations, inputs, or outputs. But we're actually not going to spend time doing that because that's actually not relevant in your profession. So what we're going to do is spend the rest of today going over the contents of chapter 1. I'd really like to remind you that I was asking you to start reading chapter 1. I really hope you did some of that Because if you haven't done any of this, this is going to be kind of hard. But you can read it in your own time and you can watch the video if you need to. So we are going to be here in chapter 1, tutorial introduction. We talked about this beginning last time. So the getting started section is what we've done before. It does a program that prints hello world. This is what you guys did the last time. You compiled it and you executed it. So everybody should be entirely fine with this part of making a first C program. We should also note that all the statements end in semicolons, and we put curly braces to separate blocks of code. Like here I have 2 blocks of code. One is the main routine, it's a block, and then there's an interior block of what's the stuff that goes inside the while loop. So that has other curly braces too. So it means that this multiplication and this increment, they're inside the while this print isn't. If I wanted to put a print inside the while, I'd have to put it inside the curly braces. So the curly braces are showing me where does the loop end and when do we return to the main flow of control. These are the 2 exercises I asked you to do last time, experimenting on introducing changes here and taking out parts of the program and looking at the error messages. So what we're doing first today is following the book's example of how to make a program that uses a conversion formula to make a Fahrenheit table. So let's see if I already have one. That's called conv. I don't, so let's make it here. So we have a formula and we want to make a conversion. First, we're just going to do the inclusion for a library. We're going to define the main, and we're going to make the main return 0 so that we can have something that we can actually compile. So I'm going to compile this conv.c. It doesn't do anything, but it happily compiles. I can also execute it, but it's not really doing anything yet. Then we want to start working about this formula. So we have 2 values. We have the Celsius. Let's call that C. Let's say I have C and the F, and this formula is written from Fahrenheit to Celsius. So let's say I have 120 Fahrenheit, and I would like to know how many Celsius degrees that would be. I will write arithmetic here, exactly like the formula says. C is going to be 5 divided by 9, multiplying the Fahrenheits minus 32. Now, horrible things will happen, but we need to make them happen so that everybody understands what's going on. Then I am going to try to print my Celsius degrees, and I also want to print the Fahrenheit to see how many Celsius is that Fahrenheit in particular. I want to print the F variable and I want to print the C variable. Let's actually add a little bit more text here so that we don't think that those are the variables, because they're not the variables, those are just text. So I'm going to compile and I'm going to execute. And it tells me that 120 Fahrenheit is 0 Celsius. I knew this was going to happen, but I also knew it's not correct. Because 120 minus 32, it should give us around 90. And that multiplied by this number, it's nowhere close to 0. So what's going on here? What's actually going on here is that I'm dividing an integer 5 by an integer 9. The integer division means that I want to know how many times does 9 fit into 5. The correct answer is it fits absolutely 0 times. So if I try to do it this way, I am going to be in horrible difficulties because it fits 0 times. If I don't want to have this kind of a trouble, I could do what they're doing in the book. I could first multiply by the 5, and then I could divide by the 9. because now it's a large number into which I am checking how many times does the 9 fit. Another workaround here, if I want to keep the formula as it would be using decimal numbers. Instead of using integers, I could use floating point arithmetic, which is for decimal numbers. So I could use, for example, floats here. I would need to put these different because I'm going to be outputting floating point numbers. And now I could happily work with these variables. Let's actually leave it here first. And I would now be getting decimal information. So I have a lot of decimal places now. It's a little bit more precise than before. So notice here, it's important that my Celsius is a floating point number because it actually has decimals. But my F, it could remain an integer because it actually doesn't have any decimals in this particular one. And if I want to keep it as a decimal, I have to put a D or an I here. Compile, execute. Now, if I would want to, this is actually interesting too. I get a different result now that I have an integer here. Why do I get a different result now? Because nobody is a floating point number anymore. So we are back to how many times does 9 fit. If I don't want to know how many times does 9 fit, if I want the decimals, I have to make sure that at least one of the numbers in my calculation is a decimal number. So if I make the 9.0 be a decimal number, I regain my decimals here. Because if all of the numbers taking part in the calculation are integers, my result will be an integer. If at least some of the numbers are decimal numbers, I am going to get a decimal result. Let's put this in a poll. So if I want my calculation to give me decimal places and not simply check how many times it does an integer fit in another one, I have to write something with a decimal. So somebody who takes part in the calculation would have to be a float. And why isn't enough that C is a float? Because this calculation here, the 5 times f minus 32 divided by 9, it happens before I assign it to C. So C being a float doesn't change anything other than I see decimals when I print it. But there aren't any decimals in this calculation unless somebody in this calculation is a decimal number. And now if I put decimal numbers here, I could write it like I wrote it before. I could write it like this. As long as at least one of these values has a decimal number in it, I am going to get decimal numbers in my result. But if none of them have decimal values in them, I am going to lose the decimals. And if I divide by the 9 before I multiply by the large number, my result is going to be wrong because I have asked how many times does 9 fit in a 5 instead of asking it what's 5 divided by 9. 5 divided by 9 is between decimal numbers, between floating point numbers. It can never be between integers. So whenever you're seeing zeros where there shouldn't be any zeros, always check. Did I by accident divide integers by integers? Because that's something you don't want to do. Your calculations don't come out like you want them to. Okay, so now we have a much larger code here in the program of the book to look at. They want to do a while loop like we were doing before. They don't want to do just one conversion. I'm only converting the 120. What they want to do is they want to start from a lower limit, end at an upper limit, and go incrementing by a step. Since they have a while, let's we do a for so that we're not just going to be like secretaries typing the whole thing. So we're going to have the int f and the float c, and we're also going to have a lower bound. Let's start from like, let's say 100 Fahrenheit. We're going to have an upper bound. We could go to 500 Fahrenheit, and we're going to have a step. We could be looking at, let's say, every 50 Fahrenheit. So now we could make a for loop. We could make a for loop where we say that f first takes the value from the lower, then while f is smaller or equal to the upper, we're going to be repeating. And after every repetition, we're going to increment f by step. We're going to make this calculation using the current value of f, and then we're going to make a printout. So now if I compile and I execute, I get this little table. Table has a lot of decimal places, so it's kind of ugly. I could tell it to cut it to only 2 decimal places by asking here for a 0.2. I compile and I re-execute. So now I have a cute little table using a for loop that's doing something that's very similar to what's going on in the book. So let me take a couple of print screens. I'm going to take a print screen from the book of the for loop and then of the for loop that we have. So the book has a while loop. It's going from 0 to 300, and it's going in steps of 20. Where did I paste it? There. And we are doing a similar logic. We're going from 100 to 500. We are going in steps of 50, and we are using a for loop to do this. I'm going to add my code to the repository. What's this example even called? It doesn't have a name, it's page 9. So important things to practice so we won't be confused is reading every single line here, understanding every single symbol. If you don't understand a symbol, ask about it. But these are doing a very similar thing. If I want them to do the same exact thing, I need to make little changes. I need to match my lower with their lower. I need to match my upper with their upper, and I need to match my step. Also, they're printing something different. They're printing a number, then they're printing a tabulator, which is a white space, and then they're printing another number. They're not printing all this text that I'm printing. So I could take the text away and put here the tabulator, and they're just using integers. So I'm just going to hide my decimals entirely to make it look the same. Come on. My keyboard has so much cat hair. It's so hard to save a file. Compiling again. Now it's unhappy because I ate the F. I just meant to take away the decimals, but since I have so much keyboard under my control, I ate the F. So much keyboard cat hair. Okay, so now I can make it print the same table that theirs is going to print. The book explains exactly what are the assignments, what are the comparisons. So this is the stuff I ask you guys to read for today. If you have any questions about any line of what's going on in the code in the book, you need to read the book. If you have any questions after you've read the book about my code, please let me know on Discord. But it's very important that you get used to reading technical texts like this. Why is it very important? Why can't you just ask me? You're going to be an engineer. I'm not going to be sitting next to you, and you're not going to be able to direct message me every time you're confused. In your work, you're not always going to be programming in C. You might be changing programming languages every year, every 5 years, every 2 months. So you need to get used to how to read documentation, how to read manuals, because stuff is going to be constantly changing. So you need to go look into what's going on. So now other things that we can notice, they are getting different numbers for some of them as we are. Why are they getting different numbers? Because they are working with integers. I'm working with floating point. So I have more precise results than they do. If I want the same imprecise results than they have, I would change everything back to integers. Notice I also have to change where I print it. I could compile and I could execute, and now I broke it because they divide by 9 at the end. I divide by 9 in the beginning. So let's divide by 9 at the end, compile, execute, and now we can see the same exact numbers they have. So the representation varies on whether you have floating point numbers or integers, and that's what they're saying here. To get more accurate numbers as results, you need to use floating points. So now they're using floats, and we're going to up our game again. We're going to use doubles. What on earth are doubles? Doubles are representations that are twice as precise as floats. So I am going to go back to having floating point numbers here, and I am going back to having, let's put 3 decimal places in here. I compile, I execute, and I get more precise results. Please read this part if you're very confused about what am I doing here with these percentages. What one's doing there is controlling how many decimal places, what kind of representation, and how many integer parts. If I want to control the integer parts, I can make my table align better, because I can see that my largest numbers, they have 3 integer parts. So if I recompile with that, I can't actually make it fill there. At least 3 characters far wide. Why can't I make it at least 3 in my floating points? Can't remember if I have to put a 0 in front of it. I think the book's so much older than my compiler. Should be able to force it in front, but my compiler isn't doing it. Let me Google this, guys. I know there's another symbol I need to put there. Yeah, it should be a 0, 0, 3. But in integers, I don't think it does it with the f, so I think we need to force it back to an integer. So let's force it back to an integer and see if it works. I'm writing Python code here, sorry guys, putting the parentheses where it isn't. Okay, so now I made them at least 3 digits long, every single one of them. So it's adding zeros in front when they were too short. And note that it's counting the negatives too. So it's a better aligned version of the table. So now I'm making my calculations as doubles, and then I am forcing them to integers to print them out. And this guy's funny. The person who's asking the question, he gives the answer and then asks, where's your textbook? This is the textbook. Okay, so 1.3, they do the stuff we already did. They do the same loop, but with a for loop instead. So this is exactly what we have been doing. And if you have any trouble with any of this, it would be important for you to do these little exercises. Many of these exercises, I have already done those for you. They are already here in the repository. So if you have trouble, you can look at them. From 1.4, we're going to learn define. I'm going to modify my convert here. Let's copy it. I'm going to call it convdef. And we're going to use this define construct from section 1.4. So now, since lower, upper, and step, they aren't actually variables, we never ever change their values. We're going to type them here as universal constants. It's a good practice to put the universal constants in uppercase so that people actually remember that those are constants. You're not supposed to be modifying them. So now I make them uppercase here as well, uppercase here as well, and uppercase here as well. I'm going to compile again my program. Now it's conf.def. I forgot the equal symbols. We don't need them for constants. We need them for variables, but not for constants. So I compile and then I execute. And the program's doing the same exact stuff. So what did I win? What I won here is that these numbers are now no longer considered variables. The compilation is going to be a tiny bit more efficient. Program's going to be a tiny bit faster because it doesn't have to think about these values changing. These values will never change. They're global definitions now called symbolic constants. So the compiler never has to think about, has this value possibly changed? It's impossible that it would change. So that's the lesson of section 1.4. Now we're going to get to the interesting part that you're going to need in your first homework, which is going to be due next week. Let's learn how to use inputs. We're going to learn this new function called getCharacter, getChar, and we are going to be reading from a text stream. It's going to be what you write on the keyboard. So let's test this. Let's learn how to read stuff. And we can practice the if more while we're reading stuff. So I could make a character. So this one's going to hold one letter. C is going to hold one letter. Then we could repeat. Let's read a letter into C. Okay, I'm reading a letter into C. While this letter is not a ending letter, I want to keep repeating. So let's see soon what's an ending letter. And if it's not an ending letter, let's say what we got with much excitement. Okay, so what's this program going to do? It says nothing, I say R. It says we get a R, and then it said we got a space, and then it gave the explanation. What's going on? I pressed R and enter. The enters count too. So if I write hola, it gets an H and O and L and A and then the enter. So basically, I could write anything I want and then have the getChar process it character by character. So no, it didn't get the word hola. It got the characters one at a time. Now, let's say I want to leave this program. I'm stuck here now. I need to send it a special character, the end of file, which is going to be a Control D. If I don't want to be dealing with the end of file, I could be checking that let's only read until we get the end of line, which is the enter. So I'm going to recompile my program. I'm going to type hola and press enter. Now it only got the H and the O and the L and the A. It never got the enter because the while stops when we have an enter. But I promised to practice an if. So let's make an if here. If C is an A, we're going to print something. And then we're just going to print what we got. So if I type hola, none of those is an A because I requested for an uppercase A. But if I type hola, it's very happy when it sees the A. And before it says it got an A, it gives me the smiley face. If I want it to smile after it gets the A, I have to print first and smile later. Compile, execute, hola. If I want it to be happy, regardless of whether it's an uppercase A, I would need to go to my reference card to check how do I make stuff uppercase or lowercase. There are very interesting things here. There's a conversion to uppercase, conversion to lowercase, and there's also checks on whether a thing is a space, whether a thing is a number, etc. So let's try these guys here a little bit in our little if. So let's make it that after we have read the C, we want to force it to be a lowercase. Let's force it to be an uppercase. So I'm going to call to upper to convert it to an uppercase. And I need to remember that I'm using a new library, C type now. And this is where the to upper routine comes from. So now, even if I type lowercase hola, the program's looking at uppercase letters because as soon as I get the letter, I convert it to uppercase. Let's make a couple of polls on Discord. And now we're going to make a little visit to online GDB because I'm a little worried that you guys can't figure out where you're supposed to type in the online GDB. It shouldn't be really difficult to figure it out, but just in case. Some people get really nervous when they're looking at new things that they haven't seen before. So it's very stressful for them. So what I'm going to do is I'm going to take my program as it is right here, going to copy it, going to go to online GDB. I'm going to select all of this. I'm going to paste my code instead. Wish I could see everything that's written here, but I don't think I can. So, okay, I could use this text version here and I could write here hola. And now if I go to, where's the select language part? I really hate how this thing lays itself out. Let's run. It says choose language, but I can't see the choice. There we go. I also hate that successfully is misspelled. So now notice the program's never going to end. Why is the program never going to end? Because it ends when it finds a new line. I'm not giving it a new line. So if I want to be able to make it stop, I need to make sure that I'm going to give it something that's actually going to make it stop. So let's make it here that it's going to stop when it sees an exclamation. And I write here my hola with an exclamation. Let's run this again. It ran it. It got the H, the O, the L, and the A, and then it finished. Because when it was equal to the exclamation, we didn't do the while anymore. We just returned. I could add here a printout to say bye when we're done. Running again. So now it says bye now at the end. So whenever your program doesn't seem to be finishing, like when we were waiting for an enter that we never got and it goes round and round and round and round, it means that you don't have a stop condition. Your cycle just keeps on going. And if you want to have an interactive console, let's see what this is going to look like. I will run this and it opens me this little black thing here. And I could type stuff there. I typed mundo wrong. And notice the program is still running. because it's going to end when I give it something that has an exclamation. If I don't give it an exclamation, it's going to keep on running. So I'm going to push this code into the repository. I'm gonna want you guys to run it. I'm gonna want everybody to choose what's your exit character going to be. You can use an X or a Q or an enter or an exclamation or whatever, but remember, you need to have one. If you don't have one defined, the program's never gonna end. You can use the EOF that I was using at first. You need to press Control D to make one. Let's say forced contact with get char. Sending it in. I'm gonna link it to you guys straight from the GitHub. What did I even call it? I called it input, didn't I? Did I even add it? I probably didn't even add it. Input. There we go, input. So this code, we're all gonna try it either on online GDB or on our own computers. We're going to type something to it. Make all the modifications you want to it. If you're very comfortable with what we're doing, make a lot of modifications. If you're very scared, make very few modifications. Compile and execute this program, type something to it, and please post on Discord a screenshot that shows both your code and what your code's doing on your computer. I need to know that everybody's on board. If someone's confused or someone has an error, we cannot continue at this point. If you feel like you're getting confused a lot, I'm going to have to ask you to spend a lot more time reading the book before the classes because there's a lot of information to take in. I'm going to pause the stream for a little while so that you don't feel stressed. When I've seen 2 screenshots, I'm going to put the stream back on to discuss the screenshots, okay? Okay, nobody except Luis is sending any screenshots. What's up, guys? You can just run my code as such, make no modifications to it. Remember that if you're using the code as is, it's going to have an enter as the ending character. You need to use an enter, press carriage return to get the program to stop. If you want it to be something else like the letter Q, you could change it. Okay, let's look at a higher resolution, what Luis is sending us. It looks much better now. Okay, so now when you include a full stop in your input, the program should finish. And if you want to see if it finishes, you can add a print of a by like I did on online GDB, that it prints something after it's done. Let me add it to print something after it's done on the repository so that you guys can take it from there. I've updated the code on the repository to include a printout afterwards. Yeah, that's what you're supposed to be doing. Just remember you need to press an enter to get the program to stop executing hide. If you want it to be something other than enter, you need to change the thing inside the while. And if you want to see whether it's actually stopping, you can add a printout outside the while right before the return, like I just did, so you can easily see that the program is done executing. I'm going to make a copy of this. I'm going to call the new copy edit, and I'm so bad at everything today that I'm opening instead of copying. And we're going to modify our program so that instead of using the printf, we're just going to make it spit out the stuff with some changes to it. So I'm going to make it so that if we see an A, we're going to substitute that with an asterisk. If we see anything other than an A, we're going to put the C back. And remember, we're making everything uppercase. So this is going to be kind of like a mom simulator. It's just going to talk uppercase. And we're also going to actually make a little like teenager simulator here. We're going to add multiple exclamations at the end of it. So I've made a little modification. Let's look at what it does and then go over why it does that. Florida, that looks wonderful. So let's look at my little program that's editing stuff. So now it doesn't print out anything anymore. And when I start writing things, it makes an edited version of it. So any A's I had are being substituted by an asterisk. All the letters are being converted to uppercase, and 3 exclamations are being added to the end. So I'm modifying my input to do something different. Let's look at how am I modifying my input. This is going to be very important for the first homework. Extremely important. So I'm still using the while to read the characters. I'm still making them all uppercase. Then I have a condition. If it's an A, substitute with an asterisk. If it isn't, put it back. And at the end, print out all of this stuff. Let's make it a little bit cooler still. I'm going to make it so that if I put something in parentheses, it's going to be skipped entirely. So I'm going to make a flag variable skipping, and in the beginning, we are not skipping. 0 is false. So now, if I see a parenthesis, I want to start skipping. So if C is an opening parenthesis, I want skipping to be 1. Then if C is a closing parenthesis and I was skipping, then I want skipping to stop. I'm going to write it like in a very long way that isn't actually necessary so that people who are beginners don't get confused. So adding two new conditions. If I see an opening parenthesis and I wasn't skipping before, let's actually write them here together. If I'm not skipping and I see an opening parenthesis, I'm going to start skipping. If I am skipping and at the same time I see a closing parenthesis, I'm going to stop skipping. If I see a closing parenthesis that doesn't match an opening one, I'm not going to do any of the skipping. Then, if I'm not skipping, I'm going to process the characters. So what's this exclamation here? It's making true false and false true. It's a negation. When something was true, it becomes false if I negate it. 1 means true, 0 is false. So if I wasn't skipping and I saw a parenthesis, I start skipping. If I was skipping and I saw a closing parenthesis, then I stop skipping. If I'm not skipping and I see an A, I put another symbol on it. So I could use a hashtag, for example, now. And if it wasn't an A, I would put a C. Let's make this a little bit more complex, make it so that it takes all the vowels out. I'm making ORs now. Still the U. So when I put 2 ampersands, it means and. It means both must be true. If not both conditions are met, we're not going to do the stuff. When I put 2 bars, it's an or. Meaning, if C is either A or E or I or O or U, then we replace it with a hashtag. If it isn't, meaning if it's consonant, punctuation, digit, then we're going to put a C in the place of it. So now I've modified my program that it's going to skip parentheses and censor vowels. Going to compile it again. Let's run it again and see how much I broke. Okay, it almost works. The only problem is that when we stop skipping, we are still printing the parentheses. And we don't want to print the parentheses when we were stopping skipping. So I need to add one tiny thing here. If I have just now stopped skipping, I don't want to do this other stuff anymore. So I could put it into an else clause, that it's only done if I did not just now stop skipping. Compile, run it again. I'm going to copy and paste because I'm very lazy. Let's put the stuff here. So now it did exactly what I wanted. All of the vowels are gone. All the letters are uppercase. All the vowels were substituted by the hashtags. Punctuation is in place. Everything that was in parentheses disappeared. Entirely disappeared. And if it's just a closing parenthesis on its own, it doesn't do anything. So this is now a tiny little editor. I'm going to push it in the repository so you guys can play with it. And I'm going to link it for you guys so you don't lose any time looking for it. So now I've made a tiny little program that it reads input using the get char, it pushes output using the put char, and it makes changes to the values. If you have any questions about the get char or put char, you really need to be reading the section 1.5. I would also recommend reading 1.52. They put counters to count how many characters, how many lines, and this is all very useful. And if we start counting white spaces that we encounter between words, we can make the program count words. So all of this stuff happens in the chapter, and all of this stuff will also be necessary for what you're going to be doing in your homework. We have a couple of more concepts we need to look at today. So we're going to have to rush to this concept. This is where I wanted to stop today. But since I found out that we actually have a holiday on the week right before the exam, we're missing 1 week of class, and we unfortunately have to look at this stuff here too. So the stuff we still need to look at is how to make arrays of data, like things that contain more than one value. So we're going to make another program for that. I'm going to call it array.c, just to learn how to do arrays. We're actually going to insert here what we had in the edit program, because I want to make a program that counts vowels and counts consonants. And I want to put those counters in a little array. So let's not skip anything anymore. Let's make an array of counters. And we have to decide what's going to go where. We're going to put in index 0 vowels. We're going to put in index 2 consonants. We're going to put in index, well, 1's consonants, 2 is going to be digits, and 3 is going to be other stuff. So I'm going to need a total of 1, 2, 3, 4 things to make counters 4. I'm not going to care about converting them to uppercase anymore, but I am very interested in whether they are vowels. So let's go look at our reference card, the part that I linked to you guys before. How can I find out if the word that I am looking at contains digits or what? So we have these functions here. Is alphanumeric means letter or number. Is alpha, it means letter. Is digit, it means whether it's a digit. Alphas are also going to, I think alphas include punctuation, but is punctuation will let me know if it's punctuation, if it's uppercase, if it's hexadecimal digit. So we have all of this stuff here in our disposal. So let's try to make the logic here. So if is digit C. So I'm looking at a digit. Then I want to increment the corresponding counter. I'm already bored at typing counter. So I'm kind of like wishing to change the names here, that this could be an I, this could be a C. So if I is a digit, then I want to increment the digit counter. And instead of writing this stuff here, it's better to put them, oh God, sorry, in definitions. So let's make a define vowel to be index 0, consonant to be index 1, digit to be index 2, and other to be index 3. So if I see a digit, I count it as a digit. If it wasn't a digit, if it is actually an alpha, like a letter, if I is alpha, then I want to check if it's a vowel or a consonant. So it used to be called C, now I'm calling it I, so I need to go change this. So if it's a letter and it's a vowel, Then I want to increment the vowel counter. If it was a letter, but it wasn't a vowel, then I would want to count the consonant. And if it wasn't a digit and it wasn't a letter, then I would want to count it as other. Then at the very end, I would want to print out how many I have of each. Note that I have to use the brackets to access values in an array. I'm so bad at typing. So I could make it print out all of this stuff here. Okay, I don't like these spaces. Let's make it a little smaller so you guys can look at it. No, it actually doesn't really fit too well. Let's just put it in the repository so you guys can look at it there as soon as it actually compiles. So let's try to compile it. Seems to compile. Now remember, I have to tell it something. Hola, 1, 2, 3, hashtag, exclamation, exclamation, lol. Okay, there were 3 digits. It didn't find any vowels. I'll explain to you soon why this happened. It found 7 consonants. It took all of these as consonants. And there's 3 other characters. 3 of them are spaces. And then there's these 3. Let's make 2 improvements. Let's make it actually find the vowels. The problem here is that I didn't convert to uppercase. So I would have to, if it's an alpha, I need to convert it to uppercase so that my condition works. And let's count the spaces too. Now remember, we have to get one more counter because I wanted to count the spaces. Compile, execute. I write the same stuff. Hola, 1, 2, 3, hashtag, exclamation, exclamation, lol. Okay, 3 spaces. Now, why didn't it reset the first one? Let's see, digit, space, C other. C is supposed to have 5 things in it. Okay, we're gonna start manually assigning memory as we should. Let me try it again just to see if it persists. Yeah, the array used to have 4 positions in it. Now it has 5, and I didn't get a reset part of memory. I got a recycled part of memory. So how do I make sure that all my counters are 0 in the beginning, that they don't contain any kind of trash things here? I could put a definition for the max here. I could make a little integer to iterate, and then I could just go reset them all. For j, that goes from 0 until it goes to max, because I need it to be 0, 1, 2, 3, 4 in every single position. I want my counter j initially to be 0. I don't want it to contain any trash that happened to be in the memory. So now it's all happy because all the counters started at 0. So I have 3 digits, 1, 2, 3. I have 2 spaces here and here. I have 2 vowels, the H, the O and the A. I have 2 consonants, the H and the L. And I have 3 other characters, the hashtag and the 2 exclamations. Let me push this to the repository. So you guys can look at it there. So we don't need to do anything more complicated with arrays at this point yet. We just need to be able to create arrays that have a known maximum capacity. We want to reset their values to be whatever initial value we think there is. Sometimes the computer is kind enough to give us free memory, so they start at 0, but don't trust it. We use the brackets to index them. It's a good idea if the indices mean words to use the definitions for them. And we have all of the concepts we've been looking at here today. We've been talking about characters. We have a for loop. We have a while loop. We have tons of if conditions. This one has even branches. If it's this, do this. If not, do this. If not, do this other thing. And then we have like the default, nothing was met once, that when the condition wasn't fulfilled, we did it. Then we have the stuff that we do after the while loop. And then we return. Let me just add the commented version. So you guys can access that. There's a lot of more explanation here. There's a lot of explanation also regarding to a switch statement. There's an explanation of how to do subroutines. We're going to postpone writing our own subroutines until next week. We're also not going to worry too much about this call by value stuff. Character arrays are very straightforward to what we just did. Don't lose sleep if any of this feels complicated. You don't need to dominate all of this today. The stuff we're going to do is going to be very simple stuff, but just remember, we're going to have to continuously be going back to concepts that we first met in chapter 1. So now I want to start using our homework system. There are many questions there that we can answer today. It's going to be mandatory to answer them before next class, because we're not going to grade anybody's code who didn't do the mini exercises. So let's go meet the mini exercises. Then let's talk about, after we've met the mini exercises, what you actually need to program. So we're going to be going to the course website. Here, when we scroll down, it's going to tell us that there are little exercises we have to do online. So you're going to go here. You're going to type in the email you usually use, the same email that we're using in the sign up for the registration. If you don't remember ever having registered, then go first to the result list, linking it to you guys too. In the result list, there's a little form. In the little form, you're going to say what's the email you want to use for your homework. You're going to type in your student number. You're going to pick your study program. If you've already done it, or if you've taken classes with me before, your study program is already going to be showing. A lot of people have never done this, so please go do this first to pick an email and to put your student ID. Once you have done this, you're going to use the same student ID to go to the homework system. It has to be the exact same email you registered. You can never change it. If you have any doubts that you might forget it, please take a screenshot of the email you're registering. I cannot change it for you. So I need everyone to do that. I should actually leave that tab open so I can see everyone doing that. All these question marks should be disappearing because you guys should be putting in your study programs. And then with that same email, you should be going to the exercise place here. When you start getting points, you're going to start seeing your points here next to the exercises. The exercise we are interested in now is the one that corresponds to chapter 1, a tutorial introduction that we were looking at now. So stuff we need to have learned are stuff like main, while, for, define, return, printf, getchar, putchar, EOF. The \0, you're going to learn it when you look at the character arrays, and extern. That would also be a good thing to know. What we're supposed to be doing here in this homework system is there are tiny little codes. Those tiny little codes tell you a tiny little thing that they're doing. Like there's here a floating point number. Its value is going to be x, which is this. Then there's an integer value, y, its value is this. Then there's another integer z, its value is this. And I'm asking you, what does this program print out? So I would like you to first try to reason on like a notebook, pen and paper, reason what's the value going to be. Because if we start that x starts at 1.621 and y starts at 15, so x is smaller than y. So x is going to be divided by z here, and then y is going to be multiplied by the new value of x, which makes y much smaller. Then we're going to check again if this fulfills. If it still fulfills, we're going to do it again. When we're done doing it, we're going to print out the present value of x with 2 decimals and the current value of y as an integer. With my values, it's going to print out 0.20 and a 0. We can check this, of course, on our compiler, and I think it would be lovely if you guys would do both things. If you first try to reason it, and then you test it on online GDB or code blocks. But if you only know how to compile it, and you don't actually know how to do it by hand, it means that you're good with the computer, but you don't really know what the while is doing. You don't really know what the float is doing. So you should really practice this. So this is just going to be exercise 1, question 1. I'm going to copy and paste this code here. I'm going to take all of the thing it tells me to run. I'm going to put it here. And then I'm going to substitute the values. X is supposed to be 1.621. Y is supposed to be 15. And we're supposed to be dividing by 2. Then I'm going to compile and execute this program to see what it prints out. Then I would copy paste this and put it here. Then there's another program where you do the same thing. You look at what your A is, where it goes, what your B is, where it goes, and what your C is and where it goes, and you reason what it prints out. So this first one, I'm checking if you've understood while. In the second one, I'm checking if you've understood for. In this last one here, we are using tiny little subroutines. And the subroutines are the parts of the book that I didn't have time to read for you because we're missing 1 week of the semester. Thanks to Independence Day. So let's just look at this code to reason it. So this is going to be exercise 1, question 3, and we're going to use this code to learn about subroutines. It also has the defines. We did spend a lot of time talking about the defines, so that should be really easy. So I'm supposed to be putting the values. F is supposed to be 3, T is supposed to be 37, and S is supposed to be 1. This one's going to print out a 17. And once you've written your answers, you're going to click on this button. You're going to wait for the button to respond. Then it's going to say graded at what time. If it says these green lines here, it means you did everything right. If it says something in red and black, it means you have a mistake and you need to read the suggestions on what it tells you. If you don't understand why you're wrong, please take a screenshot of what you answered and what the code is, what the page is saying, and we can reason together why you are wrong. The system's not going to be wrong. Tons of people have used this. It's been checked. If it says you're wrong, there's something wrong with your answer, and I will help you reason what it is. So let's learn about this subroutine thing really quickly. So here I have a main. We've had mains always. I could add here the return 0. It doesn't change anything. But this is the main. We've always had main. But now I'm saying I also want to have a thing called parity. It's going to take an integer and it's going to produce an integer. And here I have my integer j and my integer count. My j is the thing for the 4 that goes from 3 to 37 in steps of 1. If parity j gives even, even's the same as 0, then my counter is incremented and eventually it prints out what the counter was. What does parity do? Parity takes my integer, it's going to call it v. It's going to take v modulo 2. What on earth is this? It's the residue of division. So I'm dividing the number by 2 and I'm checking what's left over. If I divide 4 by 2, nothing will be left over. The result will be a 0. If I divide a 5 by 2, 1 will be left over. So the result is 1. If I divide an 8 by 2, nothing's left over. So when nothing is left over, this thing gives a 0, meaning that the number is even. So what's this code going to do? It's going to count the even numbers. So it's going to go from 3 to 37, and it's going to count all the even numbers. So what are the numbers it's going to count? It's going to count 5, 6, 8, 10. It's going to count 12, 14, 16, 18, 20, 22, 24, 26, 28. It's going to count 30. Then 32, then it's going to count 34 and 36, and that's where it's going to stop. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. Okay? So if I compile exercise 1, question 3, and I run it, it says 17. If I change these values, let's say I would be going in steps of 3. Now this is an entirely different thing because I'm not looking at all of the numbers anymore. I'm going to start from 3 and I'm going to go in steps of 3. So 6 is going to be an even number. 9 is not going to be an even number. 12 is going to be an even number. 15 is not going to be one. 18 is going to be one. 21 is not going to be one. 24 is going to be one. 27 isn't. 30 will be. 33 won't be. 36 will be. So now it's going to give me, if I compile and execute, it's going to give me a 6. I could just write here, instead of writing the parity here, I could just type here where we're sending j to the parity, right? So I could just check here the whole thing. I could get rid of the subroutine and I would be doing the exact same thing. I haven't changed the functionality. I've just made my code less easy to reuse. If some other program somewhere else needed to also check if numbers are even, now I'm not offering that functionality anymore. If I put it into a subroutine here, now I have an option that I could later on use this same code. It doesn't matter how I name it. It's called parity, but I could just call it, is this even? If I could just type even. Now, is this even looks bad because you guys are just going to think it says 7. So let's, oh, you're still going to think it's going to do that. Is even, let's under an underscore. So it doesn't really matter what it's called. And it doesn't matter what this parameter here is called. It's just a placeholder name. What's actually happening here is that main is going to send a copy of the value of j to the routine that's now called isEven, and isEven is going to let it know whether it got a 0 or not. And if I would want for the isEven to do the comparison, I could just here check that we could return if hello modulo 2 is equal to 0, which means that it's even. Cat here again. Can't save. Compile. Execute. It's doing the same thing. So I would ask you guys to use the remainder of our class hour to go answer those three little questions so that if we have any trouble, we can help each other. Under those three little questions, if we go back to look at them, that's where your real homework is. These are just warm up. The real homework is you having to write a program that does some specific things. That program that you're going to write, it is described under here. You are not to try to do this until you've done the little three things. You're going to make it very similar to what I just did with the edit program. You're going to be using getchar. You can use printf or putchar. You will not try to use file manipulation. You will not try to use scanf. I will not allow you to use anything that didn't happen in the first chapter of the book. If you're using anything that isn't in the first chapter of the book, I will take points away. It's important you write your own code. You can't copy anybody's code. If you're basing yourself on looking at my code, you will mention it in a comment. If you had to look at some other person's code too, you will mention it in a comment. You don't just copy things from anywhere. You're going to read this here. If I read it now, you guys are probably going to panic. Uh, so what we're trying to do is a program that reads input and produces an output, much like my editor that was changing the vowels and skipping the parentheses. It's almost the same thing, except that I want you to work with HTML code. Let's look at what HTML code looks like. It looks like this. So what I want your code to do is, like my code was skipping the parentheses, I want your code to be skipping the tags. When anything comes between these little arrow thingies, less than or larger than, this stuff needs to disappear. It can't be there. So all of this stuff will disappear. I also want the entire script to disappear. When a script starts, I want nothing that's inside it to show up again. So the first thing you need to do is modify my parenthesis thing to make the tags disappear. Then you're going to want to make it so that the tiny little changes that I am asking for are actually carried out. So what kind of changes am I asking for? I want that if we have a bold-faced text or section header, I want the spaces, the blanks, to be underscores. So what's a bold-faced text and what's a section header? This is a header. This is bold-faced text. Let's go look at what they look like in the source. So anything that is between a strong tag and the closing strong tag, all of these spaces need to be replaced by underscores. Kind of like I was replacing the A's with hashtags, you're going to be replacing white spaces by underscores. And you're going to be detecting these thingies the same way I was detecting the parentheses. You're going to want to figure out how do character arrays work, or you can try to simplify it a tiny bit by having two flags. One, remembering that you've started a tag, and another thing, checking if it's followed by an S. And if that S was followed by a T, you could suppose that ST always means strong, and you're just going to act like all of this is boldface until you close a tag. And if it was SC, it's going to be a script, and you want to erase the whole thing. Also, if something starts with a H1 or an H2 or an H3, those are going to be headers, and you want to teach your program to work as if those were a boldface. Don't panic if you can't make everything work, because this isn't a very important homework. If you make something work, you're going to be getting 1 point. If you make nothing work, you're going to be getting 0 points. If you make absolutely everything work, you're going to be getting 2 points. So just make any kind of a half-ass attempt. So doing nothing, 0 points. Doing at least something, 1 point. Getting it kind of right, 2 points. Those little exercises that are graded on the website, those are going to be 3 points total. All of this is going to be your first fundamental activity. That's going to give you 5 points total. So this is not a big deal. And as soon as you respond correctly, one of those mini questions, your points will show up here. So instead of saying that you haven't done anything, you're going to start seeing your points. If you already responded to something and your points are not showing up, please let me know, and I'm going to go check why they're not showing up. So between now and 5 p.m., please answer the mini questions on the website. The first 3 mini questions, this one, and this one. When you've answered them, go to the results and look if it says that you have 3 points from the exercise 1. After you've done that, first read chapter 1 of the book, then do this, because you're not even supposed to be here until you carefully read the whole chapter. So you're not going to understand the homework until you've actually carefully read the chapter. If you have any trouble understanding anything here, you will ask on the Discord channel. You will be uploading your own code. Please call it something like exercise 1. You will be putting it in your repository. Your repository needs to be linked here. If it's not linked here, you will post it on the channel so I can go add it to the list. We will be grading on our class hours next week. First your homework, then we're going to be looking at chapter 2. So remember, you also need to pre-read chapter 2 so that you won't feel lost. So to repeat, now you do the 3 little exercises. If you don't understand them well, just do them with code to put the points in now, and then do them by hand later. You need to read the entirety of chapter 1. You need to read what you're supposed to program. Then you're going to program it and you're going to put it in your repository. Then you're going to read chapter 2. When you run into any trouble, you will write something on the channel. If your code is giving you an error, you will put a screenshot. If there's a part of the book you don't understand, put a screenshot. If there's a part of the homework you don't understand, screenshot or copy paste. This is very important. I'm actually going to repeat it in Spanish. That's important. Ahora lo que necesito que hagan son las 3 mini preguntas en la página web. Necesito que los hagan ahora mismo. Si aún no sabes cómo hacerlo a mano, usas tu compilador para ejecutar el programa para ver que imprime. Yo necesito saber que tú sepas calificar las tareas en la página. Eso es muy importante. Una vez que calificaste, tus puntos van a empezar a aparecer acá. Si ya calificaste y no aparecen, me avisas para yo revisar de qué se trata. Una vez que pudiste con las mini tareas, lo que yo necesito es que tú cuidadosamente vuelvas a leer capítulo 1. Una vez que tú has cuidadosamente vuelto a leer capítulo 1, tú puedes hacer el resto de las tareas que tenemos, o sea, la parte de programación. La parte de programación viene acá después del botón de calificar. No intentes leer esto hasta que hayas entendido capítulo 1. No lo vas a entender si no has leído capítulo 1. Una vez que entendiste eso, escribes tu mejor intento de código. Este código únicamente vale un máximo de 2 puntos total. 0 puntos es no hiciste nada. Si no hiciste nada, todavía puedes sacar un 98, entonces no pierdas sueño. Si hiciste un intento más o menos decente, te vamos a dar 1 punto. Si lograste prácticamente todo lo que pido, te vamos a dar 2 puntos. Eso lo hacemos al inicio de la clase de la semana que sigue. Nosotros vamos a juntarnos en Discord, yo voy a venir con ustedes, vamos a ver los repos de cada quien, visitándolos uno por uno de la página. Si tu repo no está en la página, no te vamos a calificar. Entonces, si tú quieres que yo agregue tu repo en la página, necesito que pongas la URL de tu repo en el channel para yo poder agregarte en la lista. Una vez que hayamos calificado las personas cuyos repos están en la lista, vamos a estudiar juntos las cosas del capítulo 2, por lo cual es importante que hayan leído capítulo 2 por lo menos una vez para que no estén súper perdidos. Y luego sigue lo mismo. 3 mini preguntas de capítulo 2, vuelvan a profundizar capítulo 2, programan, suben código. Luego, siguiente clase, revisamos código, checamos capítulo, mini tareas, etc. Así vamos a estar repitiendo. So that's what's going on here. And I'm going to come with you guys on the voice channel. It's really important that you guys don't all disappear. I want at least one person. Yes, one person already has a point. So at least one person was already able to grade. Please don't leave until you have been able to grade at least one question correctly. You do not have to respond all three questions at once. You can grade as many times as you want. There is no limit to how many attempts you have. So please answer at least one question before you leave. And remember, you really have to read all of chapter 1 before you can try the programming assignment. It's going to be a pain if you have not read chapter 1. Also, try to at least browse through chapter 2 before next week so you won't be horribly sad when we're looking at all kinds of new things that you've never seen before. So I'm going to stop streaming. I'm going to give you guys the link to today's stream, and I'm going to join you on the voice channel. If you have any trouble with this grading stuff, you can share your screen and we can work on it together. If you also have any questions about the codes we did today, we can talk about those. So I'll catch you guys there in like 1 minute.